Hello friends. Welcome back to EasyDeploy YouTube channel. In this video, we are going to demonstrate on how to create CI/CD pipeline using GitHub Actions IAM role-based authorization to automatically build and deploy a sample ReactJS app and deploy it to AWS ECS fargate cluster. Okay, so what is covered in this video? Let's see. In this video, we will be creating a sample ReactJS code in GitHub repo, creating an Elastic Container repository to host Docker images, creating an ECS fargate cluster and ECS fargate service to host our Docker container, creating an application load balancer to route web traffic to the ECS fargate container. Create GitHub Actions to automatically build and deploy it in ECS fargate container on each commits to the repository. Verify the application by accessing the load balancer URL in the browser. Let's clarify some basics before we get on to the real action. So, what is a pipeline? In a software development terms, a pipeline is a system of automated processes designed to quickly and accurately move new code updates from version control system to environments like development, QA, stage, UAT, and prod. There are many advantages in using pipelines. We have listed few of them below. Removes the manual process of building and deploying the code. Hence, eliminates the need for a human resource to run the build and deploy actions. Does exactly what is defined in the code, hence it is better than having a human perform the same. As human tends to do mistakes, we can relay on codes to automate the workflows. It will work correctly, even if it is ran for million times. Simplifies the rollback. If we pushed a wrong code, we can simply roll back to previous commits to get the environment working. Improves the visibility of changes done across teams, as project managers can easily see and track changes done by each teams from the Git interface itself. Improves time to market, as everything is automated. Developers can easily embed their features to the environments, test and validate. This will improve the software development lifecycle. Prerequisites. As a prerequisite, we would need the following to get started. A GitHub account to host the codebase and run GitHub pipelines. AWS account with administrator access, or IAM user with full access to ECS ECR and IAM full access. Basic understanding of AWS, Docker pipelines, Git, and Visual Studio Code. Even if you do not have the basic understanding, it is still okay. You will still be able to follow the video and set up the environment. Let's get into some action. Now, we are going to do the following. Log in to our GitHub account. Create a sample GitHub repository. Add a sample ReactJS code in it. Create a dockerfile that defines the build commands to build Docker image for our ReactJS app. Now, I am going to open my GitHub account and click on Create New Repository. Give the repository a meaningful name. I am going to create it with name YT GitHub Actions ECS. Write down a description for the repository. I created it with description. Repository for simple YouTube tutorials on how to automate ECS deployment from GitHub Actions. Choose the repository visibility. It can be public or private. Check on Add a README file. I am leaving everything else default and click on Create Repository. Now, you can see that the repository is created. Next step is to add the ReactJS sample files. I am going to download the sample files available on the internet. Here, I have chosen a GitHub repository that has a sample ReactJS app. The link to it is in the description. If you have a ReactJS app with you, then you can use yours. I have unzipped the downloaded ReactJS app files in my system. I will now upload it to the GitHub repository we just created. I click on Upload Files. Choose the files from the unzipped ReactJS file. Please note that I have not chosen the folders. We will upload them separately. I am adding a meaningful commit message and wait for the files to be uploaded and commit my changes. As you can see, the files are all uploaded. I am going to click on Add File and further click on Create New File. The reason why I am doing this separately is because GitHub.com has a limitation while uploading folders. It doesn't allow us to upload folders. So, we need to create the folders manually, then upload the files inside folder. To create a folder, we need to add a slash at the end of the folder name and then following by a sample file. Here I create a public folder and readme.md file inside it. I am going to repeat the same steps to create src folder. As you can see, I creating src folder and readme.md file inside it now. I am adding a simple content to the readme.md file. Then I am going to commit the changes, giving a meaningful name for the changes and do the commit. Now, I am going to upload the files of src from my local ReactJS app to the repository. I wait for the files to be uploaded and then write a meaningful commit message and commit the changes. I am now navigating to the public folder in the repository and upload the sample ReactJS files from my local system's public folder to the repository. I then give a meaningful commit message and push my changes to the repository. Now, we have uploaded all the ReactJS files to the repository. Let's move on to next step in dockerizing it. In order to dockerize it, I need to create a dockerfile in the repository. So, I click on Add File, then Create New File. And name the file name as dockerfile. And write the dockerfile contents in it. The first line will download the Node.js version 18 Docker image from Docker Hub and label the container as build. The second line will create a /app folder. The third line will change the working directory to /app. The fourth line will copy the codebase from repository to inside container. The sixth line will install the node modules. The seventh line will generate the build output. The ninth line will download the HTTPD image from Docker Hub. The 11th line will copy the /app/build folder built from 7th line to the /usr/local/apache2/docs folder. The /usr/local/apache2/docs is our Apache images default document root. The 13th line will change the ownership of the Apache document root to www.data. I commit the changes to Dockerfile to the repository by giving it a meaningful commit message. Okay, this concludes the ReactJS project setup in the GitHub repository. Let's go back to our PPT to see the next steps. Next, we will be creating a bunch of items, namely ECR, task definition, ECS cluster, ECS service, application load balancer, Let's first create an Elastic Container Registry to host the Docker images that will be pushed from GitHub pipelines. Let's go to AWS console and search for ECR and select Elastic Container Registry. Click on Create Repository and give a name. I am creating with name YT GitHub Actions ECS. I leave rest of the items as default, as these are not covered under the scope of this video, and click on Create Repository. Now, let's move on to next step. The next step is to create task definition in which we will define the container resource allocations such as RAM, CPU, container image, container port, etc. Let's go back to our AWS console tab and search for ECS and click on Elastic Container Services. Now, click on Task Definitions, then click on Create a new task definition. Give a name for the task definition. I am creating with name YT GitHub Actions Demo. Scroll down to Container section. Give contain a name. I am giving it YT GitHub Actions ECS Demo. In the image URI box, copy the ECR image URL and paste it. Then add a image tag. I am adding the tag as latest. Since we are running a Apache container image, let's leave the container port as 80 and name the container port as HTTP_port. I am leaving everything else to default and click on Create button, as they are out of scope for this video. Now, we have created the task definition. Let's click on JSON tab and click on the Download JSON. We will need it later in this course. Let's now move back to the slide. Our next step is to create ECS cluster to host our ECS service that will call the task definition we just created and add application load balancer to expose the container to outside world. Let's switch back to AWS console and click on clusters. Now, click on Create Cluster. Give cluster a name. Here, I am naming it as YT GitHub Actions ECS Demo. Then, scroll down and click on Create button. This will invoke a CloudFormation template to create ECS cluster. The cluster creation would take up between 1 to 2 minutes. Let's go inside the cluster. While the cluster is still in provisioning state, we can move on to next step of creating a service. Let's click on Create button. Scroll down to Task Definition section and choose the family. In the drop-down, please select the task definition you created earlier, and in revision, please select the latest. Give a name to the service. Here I am naming it as YT GitHub Actions Demo. Scroll down to Load Balancing section and choose Application Load Balancer. This will have the container selected already. Give Load Balancer a name. I am naming it as YT GitHub Actions ECS Demo. Scroll down to Target Group Name. I am editing it to have a more clean name. Since it is a ReactJS app, we can define the health check path as /index.html. Next, scroll down and click on Create button. Create service will invoke another CloudFormation template. This process will take up to 5 minutes. While it is getting created, let's move to next steps. Our next step is to prepare GitHub authentication to our AWS account. As a best practice, I am going to use IAM assume role for the authentication, and not going to use AWS access or secret keys. In this step, we will be creating OpenID Connect Identity Provider. IAM role for GitHub pipelines. Grant ECS and ECR permissions to the IAM role. Attach trust relationship of identity provider to the role. Let's go back to our AWS console and search for IAM. In the IAM page, select Identity Providers section. Click on Add Provider. Choose OpenID Connect. In the provider URL, paste https://token.actions.githubusercontent.com and click on Get Thumbprint. In the audience box, paste sts.amazonaws.com and click on Add Provider button. Next, select Assign Role button that you see at the top of the page. Then check Create a New Role and click Next. On the new page, scroll down to Audience drop-down box and select sts.amazonaws.com. For the organization box, go back to your GitHub account and copy-paste your organization name. Copy-paste your repository name in the repository box and click Next to add permissions. Here, I am adding Amazon ECS full access and Amazon EC2 container registry full and Amazon EC2 container registry power user access. I would recommend granting only fine-grained access when you use it for your organization. Click Next and give role a name and a description. I am naming it as GitHub Assume Role and adding a description as GitHub Actions to authenticate and authorize to AWS account. As you can see in the Trust Policy box, 18th line, your GitHub organization name and repo name will be populated automatically. Now, click on Create Role. Click on the View Role icon visible on the top right of the page and keep this page open, as we will need the IAM role ARN in the upcoming steps. Let's switch back to our slide to see what is our next step. Our next step is to set up pipeline to automatically deploy changes to ECS and verify the deployed app URL. Let's go to our GitHub account and choose Actions tab. GitHub offers a lot of pre-built workflow files. Let's take advantage of it for our requirements. I am searching for ECS and select Deploy to Amazon ECS Workflow. Click on Configure. This will create a file called aws.yml repository at .github/workflow/folder. Let's customize the workflow file to our environment. I am going to change the my_AWS_region to US East 1. My_ECR_repository to the ECR repository name that we created, that is YT Action ECS. my_ECS_service to the ECS service name we created YD GitHub Actions demo. my_ECS_cluster to the cluster name we created YD GitHub Actions ECS demo. my_ECS_task_definition to .github/workflows/YD GitHub Actions demo revision 1.json. This is the name of the task definition file we downloaded earlier in this video. my_container_name to the container name we created inside the task definition. Let's scroll down the workflow file further to replace the AWS access and secret key section with our AWS IAM role ARN. Remember I said we are not going to hard code the AWS access and secrets keys and use the best practices to use IAM assume role. I am going to give the IAM assume role a session name. I name it as GitHub assume session. Since we are using IAM assume role, we need to grant the GitHub pipeline a write access to add the token in the pipeline. So, I add it under permissions section of the workflow file. I also change the AWS credentials workflow version from v1 to v3 and commit my changes. Our next step is to upload the task definition JSON file to the path we defined in the workflow file. The path we defined was .github/workflows/YD GitHub Actions demo version 1.json. Now, we are done setting up the GitHub pipeline. Let's go to GitHub Actions. We will see two pipelines running. Let's cancel run on the first pipeline. I cancel it because the first run will fail as that commit would not have the task definition JSON file. Let's go to the second pipeline and see the logs. I see that the pipeline is still building the Docker image. Let's go to AWS ECS Services tab and see the tasks list. There will be stopped tasks as the first task definition we created would not have any Docker image in the ECR. As you can see, the task definition revision was 1. That was using the latest tag in the image URL. Let's refresh the services to see if there is a change in the task definition revision version. This is an expected behavior as the pipeline is still running. The task definition version would increment on each pipeline completion. As we can see, the task definition revision version is still 1. Okay, the deployment has just begun. You can see the last deployment status is changed from failed to in progress. Also, the task definition version is changed to 2. This would take some time to complete. It will take some time to be added to the load balancer. By that time, let's go to the ECS services and get the target group attached to the ECS service and get the load balancer DNS URL. Let's copy the load balancer DNS URL and paste it in the browser and try accessing it. Ta-da! We have the ReactJS application up. Meanwhile, the pipeline is also succeeded. Awesome! Let's go back to the slide to perform the final steps. In this step, we will be making a simple change in the index.html file and see if the pipeline automatically deploys the changes. Let's go to the repository and open the index.html file inside public folder. Click Edit and modify the 27th line replacing title React App to React App v1 and commit the changes. This should change the index.html page's title on successful completion of the pipeline. While the pipeline runs, I am going to show you some items that will be helpful for your knowledge. Each Docker images created from the pipeline will have the same commit ID hash created from the GitHub repo. This image tag ID will be modified automatically by each task definition revision that is created by the pipeline. Here, let's open the task definition version 2, created from our JSON file upload commit. This should match the same commit ID created from GitHub while we uploaded the JSON file. Let's open the commit history to get the full commit ID of the JSON file upload and copy it and compare it with the version 2 commit ID. I press Ctrl+F and paste the commit in the browser, and I can see it matches the commit ID. Now, let's copy the latest index.html file edit commit ID and see if the task definition version 3 matches the same commit ID. Perfect, it does matches. Let's wait for the deployment pipeline to complete. And then access the load balancer DNS URL in a separate tab to compare if the app title reflects the changes we made. I am going to pause the video until the deployment is complete and resume again. Now, the deployment is complete. I have opened the load balancer DNS URL in another separate tab. You can see the page title has v1 added to it. The conclusion. In this video, we have created a GitHub repository. Created ECR, task definition, ECS cluster, ECS service and application load balancer to host the ReactJS container. Created IAM role to grant access to GitHub repository's workflow. Created pipeline and run the same. Tested the automation by making changes.